of the cracks into this large water vapor plume that you can see in the background there. We had an internal heat source. We had organic material. And what you also need in addition to those three ingredients is you need them to be stable enough over a long enough period of time that something can actually happen. And so there's now a real focus on Enceladus as one of the places in the solar system where potentially life might be able to form. And there's some plans for us to be able to go back to Enceladus. And in fact, it was the focus that we had on Enceladus with Cassini that allowed us, enabled us to persuade the European Space Agency that the next large planetary mission that we wanted to do was JUICE. And so let me talk a little bit about JUICE. So JUICE is a spacecraft mission which we're building at the moment. You can see a view of the spacecraft in this image here. Shows you very clearly that we're going to use solar power out at Jupiter. You can see the large solar panels there. And the plan with JUICE is that we're going to focus not only on the Jupiter system itself, but really focus on the large moons of Jupiter. We want to try and get an understanding of what the conditions are like at these moons to try and get an understanding about whether life might be able to form at these moons. And so, as is listed at the bottom of the slide there, we're going to have two flybys of one of the moons called Europa. We're going to fly past Callisto, one of the other moons, on 10 separate occasions. And I think right at the end, I've got a slide that shows you the interior structure of these moons. And then last but not least, and most importantly from my perspective, is we're going to go into orbit around Ganymede. And this shows you a view of Ganymede. We think there is liquid water underneath the surface of Ganymede. And the instrument that I'm building, the magnetometer, will allow us to actually measure the electrical currents that are flowing in that liquid water and allow us to get an understanding about not only how deep the water is, but what its salt content is as well. And the reason that we really wanted to focus on Jupiter is, and it points to, I think, one of the most important realizations that we've made in the last 30 years. And that is that you can find liquid water quite far away from the sun. You know, previously to this, we had always thought that you had to be close to the sun to be able to get liquid water. You can only have liquid water on the surface of planetary bodies, and to be able to do that, you need to be close to the sun. What we found with Cassini, what we found with the Galileo spacecraft previously at Jupiter, and what we're going to focus on with JUICE at Jupiter, is that you can get liquid water at some of the moons of these planets in the outer solar system. But of course, they're not going to be on the surface because it's too cold. The liquid water is going to be underneath the surface. And so we're really going to use the JUICE spacecraft to be able to focus on trying to get an understanding about what it is that makes a planetary body habitable. So that's going to be the main focus. So I've got two more slides before I open this up. And that is, this one here shows you a view of the instrument that we've built. So it's been rather stressful. We had to shut the department down. We had to shut all of our labs down, but we still had to continue to build the instrument. We were really fortunate that we were able to reopen our labs in June of last year. We've had to be socially distanced, but we've been able to bring the engineers in and build the instruments. And so the instrument, this shows you the flight instrument that we're about to deliver to the European Space Agency. There are 4 separate parts to it. This is the electronics box, which is going to be on the main body of the spacecraft. And then we've got 3 different instruments. There's an instrument that will be halfway down the boom that was built at our colleagues' institute in Germany. We have the instrument that we built at Imperial College, which is going to be close to the end of the boom. And we also have an instrument that's going to be right on the end of the boom, which was built by our colleagues in Austria. And we've got the instrument down in our lab at the moment. We're doing the final sort of touches to it now, and it will then be flown over to the European Space Agency, where it will be put on the spacecraft. And I think I will then show this final slide, which essentially shows what the focus of the JUICE mission is going to be. It's going to be on Ganymede in the top right. We're going to into orbit. To be able to understand a planetary body, you really need to go into orbit. You need to be able to separate the temporal features from the spatial features. We're going to get an understanding about how deep the water underneath the surface is and what its salt content is. We're also going to study Callisto, which we think too, oh, sorry, let me go back, which we think also has a liquid water layer, which you can just about see, this pale blue region here. And then Europa, we're going to have 2 flybys of Europa, but we're hoping to do this in conjunction with NASA, that is going to send another mission called Europa Clipper to Europa at the same time. So Imogen, I will stop there and take any questions that people have. Would you like me to stop sharing my screen?
Thanks, Michelle. Yeah, we'll if I could ask the Q&A folks in the committee to share their screen onto the VVox questions. Brilliant. Thank you, Denny. So thank you very much for that talk, Michelle. That was a wonderful insight into Cassini and JUICE.
Thank you.
And yourself as well, of course. So we've got a few questions here. I'll go down the list. So our top question is, what have your experiences been of missions and projects coming to an end? With missions spanning over many years, do you find it difficult to finish them? As an example, the Cassini mission, which finished a few years ago. The question asker remarks that they remember feeling very emotional about it themselves.
Yeah, it's a good question. It is very emotional. You know, I spent 20 years of my career working on Cassini. What was interesting, and you almost become a family. You know, you work with people day in and day out. We had a team members spread around the world. We would spend long times on teleconferences and video conferences, and so you get to know people really well. What I found so interesting is, as we got to the end of the Cassini mission, the last 6 months of the mission was exhausting for all of us. We had flybys, close flybys to Saturn every 6.5 days. And we'd almost got to the stage where we thought we can't keep up anymore. It will almost be a relief to have it all over. And then it ended, and you suddenly think, oh, I don't really want it to end. But by then it was too late. It was all over and done with. It was extremely emotional for me. For me, I think the most poignant moment was I was out at the Jet Propulsion Lab watching the end of the mission. And what we did is there was a graph that we were looking at, and there was a big spike on the graph. And what that spike was telling us, that the spacecraft was actually talking to the Earth. When that spike disappeared, that was it. The spacecraft had burnt up in the atmosphere. And we were all watching the spike, and it disappeared. And then it came back again. And the reason it came back again is the spacecraft had been designed to talk to the Earth. And so if it needed to move to do so, it would do so. And no one had, in fact, told the spacecraft the mission was coming to an end. So it was beginning to tumble, but it knew it had to keep talking. And so it moved itself so it could continue to talk. And then it finally lost lock, of course. But that is what does it for me. It was almost as if, you know, it kept trying and then it couldn't do it anymore. Sorry, Imogen, I didn't mean to upset you.
I know, it's so tempting to personify these machines, isn't it? But
it is.
You know, when you're working with them for so long, it's just, you know, very easy to do. Next question. Are there any particular skills or experiences you think would help a student begin a successful career in the space industry?
Well, you know, having a good background in maths and in science is important. But for me, I think the most important thing that I learned is that you shouldn't be afraid to take on something that maybe you don't think you can do. I was originally asked to take on the Cassini Magnetometer team by the original principal investigator, who was moving on to another role somewhere else. And I didn't think I had the experience. I didn't think I had the expertise to do it. David Southwood, who was the person who asked me, saw something in me that I didn't see. And if I hadn't been brave and terrified and said yes, I wouldn't be doing what I'm doing today. So I think it's grasp opportunities that come your way, and if you have to learn on the job, then go for it.
Great, thank you. Next question. Do you think there are many opportunities for space research and careers in the UK, or is it important to be open to moving elsewhere in the world?
I think there are many opportunities in the UK, and I think since the UK Space Agency formed, what, 5 years ago now, since we're now building up not only we haven't only got a really good science base of space and planetary science, but an industrial base as well. I think there are huge opportunities in the UK, but I also think it's important to gain experience elsewhere. So I think if you have an opportunity to have a contract somewhere else, I think it's really good to do that, because you know, working internationally allows you to gain experiences that you wouldn't get if you stay in the UK. So I think it's important to be open to moving somewhere else, even if it's for a short sort of period of time.
Yeah, thank you. Next question. Did you find it hard to get into space physics having studied mathematics and not something like astrophysics or astronomy?
Looking back, I'm still surprised that I ended up doing what I'm doing. I think I was really fortunate because my local university was willing to take a chance on me. I think my maths background served me really well. I think it will be much harder to do it today, to move field so completely, because I think it would be almost impossible to get into a university without having done science, to do a science degree. But I think it goes back to the answer I gave to one of the previous questions. I was asked to get involved in something that I didn't have experience in, and I almost had to learn on the job. And I think that's what's important. Put in the extra work to gain the experience that you need to be able to do what it is that you said you're going to do.
Great, thanks. Next up, are you most interested in Jupiter and Saturn's lunar environments, such as atmosphere, weather, geology, and the possibilities of habitability? Or do you find the planning and engineering of the probes and the instruments the most intriguing and fulfilling these days?
I am a scientist. It's a science that drives me. And for me, that's always the most important thing. But in fact, being involved in the JUICE mission at this very early stage has been really interesting, because, you know, in some ways, I was really fortunate on Cassini. I wasn't involved in building the instrument, and I was able to get involved when all the exciting science happened. And so, in some ways, I see JUICE as a way of paying back almost. But for me, the really interesting thing about being involved in building the instrument and interacting with the European Space Agency and the engineers is it's a different dynamic and a different focus, because the ESA engineers and project team want to build the best spacecraft. I don't want them to build the best spacecraft. I want them to build the spacecraft that will allow me to do the best science. And that's not always the same thing. And so it's very, you know, the discussions that I'm having at the moment are very different to those that I'm going to have once we're there and we're taking data. So it's been a very useful insight. And I wish I'd had it when I'd become involved in Cassini, but you can't learn everything at the same time.
Yeah. What's next? How pivotal do you think your family have been in your career choice? If your father wasn't an engineer, would you have been as confident in pursuing this career path?
Probably not, actually. I think I was really fortunate. I was never made to feel that because I was a woman, I wasn't able to do what I wanted to do. I think having my dad able to help me get through those first couple of years of university, essentially going through the physics and the chemistry lecture notes with me, really helped. But I still have to pinch myself. I ended up doing what I do, because I remember my first view of Jupiter and Saturn was when I was a kid. My dad built his own telescope. He actually ground the mirror of his telescope and everything. Wow. And I remember my sister and I were so excited. We mixed the concrete to make the base of the telescope. And of course, we thought that was the most important part of the telescope. But I remember my first view of Jupiter and its moons and the first view of Saturn and its rings was through a telescope in our front garden, never thinking I would end up doing what I was doing. So I've been really fortunate. I made some decisions to do stuff that I didn't think I had the experience of doing, but I did anyway. But yes, going back to the question, I was really fortunate in the family that I had. They allowed me, they enabled me, they gave me the confidence to do what I do.
Great, thanks. Next up. Oh, how did you find moving internationally as part of your career from South Africa to Germany to the UK and so on?
It was scary as hell to begin with. I think that was probably the scariest thing I've ever done, was leaving South Africa and going and living in Germany. I mean, I really enjoyed the 2 years in Germany, but it was pretty scary. When I came to the UK, because it was an English-speaking country again, it felt much easier. Originally I only had a 2-year contract at Imperial, but I got married. I really was enjoying being at Imperial, and I've been here ever since. So I've actually lived longer in the UK than I lived in South Africa. But for me, the scariest step was that first step, was actually leaving South Africa.
Wow. Yeah, as someone who hasn't had to move internationally for a career yet, I think it sounds scary. but yeah, for sure. Next up, you've mentioned Europa, Enceladus, and a few other moons as promising locations to continue a search for life. What's your take on Saturn's moon Titan and a possible return to there?
Yeah, Titan is a strange place. We know that there is a liquid water ocean underneath the surface based on gravity observations from Cassini. We also know there is liquid on the surface, but it's not liquid water, it's liquid ethane and liquid methane. There is actually a mission that's being designed at the moment, I've forgotten its name, but it's going to consist of a balloon and a little helicopter that's going to fly around the surface. So there is a real focus not only on Titan, but on Enceladus. Titan is easier to go into orbit around, because Enceladus, even though we want to go into orbit around it, because it's so small, its gravitational field is very small. So that means you need a huge amount of fuel to be able to slow down enough to go into orbit. But yeah, I think my preference would be to look at both Titan and Enceladus as places where there might be life of some kind.
Great. So sort of following on from that question, the next question we have is, how do you know which of the moons to focus on first?
You base it on the knowledge that you build up. With Jupiter, for example, there were numerous spacecraft, the Pioneer and the Voyager spacecraft, that flew past Jupiter and had single flybys of some of the moons. There was then the NASA Galileo spacecraft, which actually went into orbit around Jupiter, so spent a long time there. And it was Galileo that made the measurements with the magnetometer that there was liquid water underneath the surfaces of Ganymede, Europa, and Callisto. And so in some ways, I see the Galileo spacecraft as the discovery mission. With JUICE, we're now going back to look at it in detail. And so you make these decisions based on the knowledge that you build up over time.
Great, thanks. And a topical one, actually, the next question. So yesterday, there was a press release about a result based on M82, supermassive black hole, which had its event horizon imaged last year very famously. And this new result was remote sensing of the magnetic field in the accretion disk of that black hole.
Yeah.
So the question here is the magnetometer a piece of equipment that can be used to develop these images and understanding of black holes further?
Not at the moment, because the magnetometer is an in situ instrument. So it measures the magnetic field where it's at. And so you can't remotely measure the magnetic field with a magnetometer. So, and it would take so long. I mean, I lose patience when it takes us 8 years to get to a planet. To get to one of these black holes will probably be my great-grandchildren's great-grandchildren before we get there. But also, the instrument wouldn't be able to survive the black hole. It would be broken apart, I'm afraid. So as important as I think magnetometers are, and I bore people telling them that the magnetometer is the most important instrument in the world, I don't think we could do anything on this front, I'm afraid.
Very good. Okay, I think I'll do one more question from this set before we move on. But this top question here is, how do you keep the passion and interest in the field whilst working tirelessly on the same thing every day?
Because I don't work on the same thing every day. What my job consists of is very varied. I work with the engineers to make sure that they will build the instrument we need to do the science. I have PhD students and postdocs who work with me on science from Cassini. I teach. I try and keep the department operating in difficult times like COVID. And so it's many and varied. There are actually times when it would be good just to focus on one thing, but I don't quite seem to manage it. So that's how I keep the passion and interest going, I think, is to do lots of things at the same time.
Thanks. Okay, I think we're about at the stage where we're going to bring this Q&A portion of the talk to an end. I think what we'd like to do next is invite everyone to move into the gather space to have a more interactive chat with Michele and any other participants. We do have a discussion room set up if you walk to the right in the gather space. So I encourage everyone to go in there, and I hope, Michele, you have some time to stick around.
Imogen, sorry, can you remind me how to get there?
Yes, we will put a link in the chat.
Oh, good.
It's just appeared there. Although before we all sign off to jump it together, I do have one last question.
Of course, go for it.
A selfish question, but also I think broadly a broad interest. If you had one piece of advice that you would like to give to the undergraduate women here, what would that be?
Be brave. Don't stop yourself doing something because you think you're not experienced enough. Take a chance. And if you have to learn as you go, that's what you need to do. But I think be confident in your abilities, I think is probably one of the most important things.
Thank you very much. Thanks. And thank you for sticking around for this. Thank you for coming. It's been wonderful to have you, and that was a very interesting talk.
Thank you, Imogen. Okay, I'm going to click on the gather space before it disappears.
Oh, yes. We may need to post that again.
Yeah,
again,
would you mind,
as it comes through.
would you mind posting it again? Yeah, thank you.
Yes.
Okay, no, I see it. Perfect. Okay, see you shortly. Thank you.
Thank you very much, Michele. Bye-bye for now.
Bye.
I've stopped recording.